And it turns out that the relevant growing season rainfall shock for your pixel, for your crop, in the previous year is an extremely strong predictor of violence the next year. But rainfall outside of, say, the 3-month growing season for your staple crop has no predictive power on violence. So if you think it's just, say, high temperature leads to aggression and leads to lots of violence, then high temperature outside the growing season should do so as well, for instance. But they're very much making the case that it's the lagged rainfall shock from your last harvest that's basically driving the violence. So, even though the instrumental variable approach that we use, there are these very plausible violations of the exclusion restriction. Some of the new microevidence is suggesting economic factors are pretty important. So that's how we view it. Yeah.
So you said the importance of the sport in
Yeah.
research.
Yeah.
It seems like you place emphasis in the whole course on understanding ecology.
Yeah.
So from the perspective of the usefulness of empirical work,
Yeah.
how useful is the emphasis on the reduced form?
The reduced form is still a causal relationship. It is the causal impact of rainfall on violence. And we can debate about the channel. No, but that's why you have to understand the mechanism to some extent. You could say, well, now we've identified areas at risk of violence, areas hit by rainfall shocks, and we have to do a series of further policy experiments or randomized experiments to try to understand how to help people insure against those shocks or understand what's going on the ground. And so, like, this new paper suggests it's really an agricultural shock in Africa that matters. So we've identified at-risk areas, and we have to come up with some sort of agricultural insurance policy, say, to deal with. So it's still a causal relationship. It isn't as tightly linked to a theory, let's say, as it would be if we could link it to economic growth, because that has much broader implications potentially, right? So economic shocks not driven by conflict would still matter, et cetera. So when I say people are looking at reduced forms, that's certainly the case in this climate conflict literature. I think enough people feel like the IV assumptions are too strong. It's true in general in cross-country work. So we talked about Acemoglu, Johnson, and Robinson about a half ago. We talked about how they said, look, cellular mortality affects institutions, and institutions affect growth. Not everybody believes exclusion restriction in that paper. In other words, the poor health conditions that led to high cellular mortality could have affected a lot of things, not just a very particular type of legal institution or property rights institution. So I think I mentioned in passing, we didn't really go into detail, I don't think, in discussing Nathan Nunn's work on slavery in Africa. I think I mentioned him briefly. So Nathan Nunn is an economist at Harvard, economic historian, who tries to understand the implications of the slave trade. And I think we kind of alluded to this, we didn't go into in too much detail. He basically shows reduced forms. He basically says areas that were hit by slave raiders are poor today. And they have all these other characteristics that are plausible channels. It's very much like what I told you before. He shows all these like pseudo first stages. He's like, these areas that were hit by slave traders are less democratic, they have more ethnic divisions, they have more corruption, like all this stuff went wrong that sort of produces lower income levels. But he's not going to take a stand and say it's like this one channel. And that's really, I think it speaks to the evolution of the style of empirical work, a lot of empirical work using IV methods in economics. If you go from Acemoglu, Johnson, Robinson to Nathan Nunn's work, which came out in 2008, or if you go from our work, which we wrote in 2003, to the more recent work on climate and conflict, people just don't believe exclusion restrictions as much. They're more skeptical, which is good. Yeah. Yeah, they're just saying we're going to look at the weather shocks and show you the impacts. But in order to make some progress on mechanism, they do this thing about growing season for your crop versus non-growing season, which they interpret as saying, look, we think agricultural income is the key driver because it has basically all the predictive power. Temperature and rainfall outside of the growing season window have zero effect, and in the growing season have this huge effect. So they're kind of using their very finely grained data to get at the mechanism, but they're not trying to do an instrumental variables approach. So it kind of speaks to this style of work. Okay, 3 conditions: relevance, exogeneity, exclusion. Memorize these. I want to do these graphically because it's kind of fun to think through the logic of this as if this was again more of a philosophy class. Relevance is the bold stuff there. Relevance means rainfall growth is affecting economic growth with that sort of causal arrow. It's driving economic growth. That's relevance. That's the first stage. I think that's the easiest one to understand, and everybody's on board with that. Exogeneity. So this is my attempt to convey what's going on with exogeneity. Exogeneity means, what does it mean? All those other X's that could matter, that could drive growth, that could drive war, are not affecting rainfall growth. X does not lead to rainfall growth. Moreover, conflict or war also does not affect rainfall growth. Rainfall growth is exogenous. It's like a natural experiment. It's not being pushed around by all these other variables in the model. Not the omitted variables, not the outcome variable. That's exogeneity. And then exclusion restriction is a little simpler to convey, which is to say rainfall does affect economic growth, but it doesn't affect war through any other channel, like aggression, say, or road quality, all the things we were talking about. So I think these diagrams logically will give you some sense of what these assumptions mean. And if you have a variable that satisfies them, you have a good instrument, and you should be very, very happy. Because good instrumental variables are hard to find. Okay, let me pause and see if there's any questions or comments on this. Just as a broad background question, how many people have studied instrumental variables methods in your econometrics classes or statistics classes? Okay, so most people have, some people haven't. How many of the classes had a red thing like this on it? Okay. This is new. This is new. I didn't think so. Hopefully this makes it a little more comprehensible. I remember the first time I studied IV methods in a econometrics class, I just didn't know what they were talking about. Because there were the matrices, we inverted the matrices. They said, okay, you invert the matrices, that's an instrumental variable. I had no idea what they were talking about. So hopefully this is a little bit more useful. Okay, so let's write down equations. How are we going to operationalize this? And I'm going to go through what we did in the paper, subject to these caveats. Let's talk about the reduced form next with a subscript 0 here. The reduced form is the outcome of interest, in this case war, regressed on the instrument, rainfall growth. So the coefficient estimate for the reduced form is B0, B0. What does that look like in the data? This is in table 3. There are 2 different definitions of war in the data sets that were available at that time. Right now, with what Harari and Mafarani have, they have these incredibly disaggregated measures of where conflict and violence took place, but at the time they had country level data. So that's what we use. And for some of them, they define, as I talked about before, civil conflict greater than 25 battle deaths per year or 1,000 battle deaths per year. So you can sort of take your pick on which one you like. With the 25 battle deaths per year, both point estimates are negative, and when we look at the lagged rainfall measure, we get this significant negative effect. Where rainfall was growing last year, we have less conflict this year, with a T-stat of 2.5 or something like that, 2.4. With the 1,000 battle deaths threshold, the higher threshold, actually both current and lagged rainfall enter in statistically significantly. With, again, T-stats of about 2 to 2.2 or something like that. So kind of more borderline significant, but still significant at 95%. So this is the reduced form, where rainfall is growing, where rainfall is getting better in sub-Saharan Africa. And again, you could do this with deviations from mean rainfall. Where rainfall is getting better, you have less armed conflict in the data. Where rainfall is getting worse, So when you have a big drop in rainfall, so you have a drought, say, the risk of conflict increases. Yeah. Yeah, there are common axes. I've been very quiet about all these other rows down here, like country fixed effects and country time trends, just because understanding the panel data with fixed effects is another discussion that we could have another lecture, you could have in section. But there are the same controls in the reduced form as the first stage and the second stage. And the thing that helps us out here is if you remember our omitted variable bias formula, what helps us out when there are omitted variables is if the variable of interest here is uncorrelated with those omitted variables. And that's why it's so important to have exogeneity. That's why it's so important that the rainfall shock isn't being driven by, say, the local observables. Right? So that saves us here. But maybe next lecture, another time, we can talk about country fixed effects, but I don't want to go down that road right now, because I want to focus on the IV right now. So this is the reduced form. Okay, I showed you the first stage. I showed you the reduced form, and then the original regression of interest is what's called the second stage, the regression of war and economic growth. So now you see all three equations. And now imagine we buy the IV assumptions, and what we care about is B2. How are we going to get B2 out of the first stage in the reduced form? That's the question. We want B2. And it turns out the first stage in the reduced form give us B2. And that's what's cool about exponential variable methods. How do they do that? This is the intuition. Think back to the reduced form, and assume our IV assumptions hold. If rainfall affects growth, and only affects war through growth, that's the assumption. And we show in the reduced form that when rainfall is good, that has a big effect on war risk, then it's more likely that growth has an effect on war risk. In contrast, if despite filling all the IV conditions, so rainfall drives economic growth, it only affects war through economic growth, there's no correlation between rainfall and war, it seems much less likely that economic growth is a big factor driving war, because we have something, a natural experiment rainfall, that's leading to lots of exogenous variation in economic growth. And if despite all that exogenous variation driven by this natural experiment of rainfall, despite that, rainfall doesn't correlate with war, it seems very unlikely that growth would be driving war. Okay, so these are the 2 points. If we find a very strong relationship in the reduced form under the IV assumptions, then that would imply that economic growth is driving war. If we don't find a relationship, it seems very unlikely that economic growth is driving war. Does that make sense? Let me pause. Let's not think in terms of matrices and equations, but just think in terms of logic. You know, there's a variable that moves around another variable. That's the way I think about it. The instrument is moving around growth. Yeah.
You can always do it as the transit property, right? It's having B, but it's having B, having C, everything else C, right?
Under certain assumptions, yeah.
With all the
With all the
caveats.
caveats, yeah. That's basically the way to think about it. And that's why the exclusion restriction becomes so important. When you put it that way, you see why it's so important. Because if it doesn't hold and there's lots of other channels, then you're breaking the causal link from rainfall to growth and growth to war. So this is actually what the estimator for B2 looks like in a two-stage least squares estimate. This is basically what Stata will run when you run a standard IV regression in Stata. It's also called a wall estimator. B2 is the effective economic growth of war, the causal effect of economic growth on war. And this is the ratio of the estimated IV impact, the impact of the IV on war, divided by the impact of the IV on growth. So this is sort of the rescaling. The IV is moving around growth a certain amount, and it's moving around war a certain amount. If the only channel through which it works, the IV, is growth, then the ratio of those two things tells you how much growth is affecting war. See that? That's the logic. That's the intuition. All the movement here is driven by the natural experiment of rainfall. So we get this ratio under the assumption that all the movement in war is coming through growth. So what we want to do is basically just get the ratio of the reduced form estimate on the first stage estimate. That is the intuition. Now, there's an algebraic way to show this that may be more intuitive for some people. Some people find this more intuitive. Some people find the algebra more intuitive. So let's go through and, actually, I'll show you what the estimates are first, and then I'll show you the algebra. So, actually, I'm going to jump to the algebra, because actually I feel like the algebra makes more sense. Let's go to the algebra, and then we'll go to the magnitudes. You can get this ratio directly by plugging the first stage into the second stage. This is the trick with IV estimates. Take your second stage estimates, plug in the first stage. So that first row is the second stage, war, regress, and economic growth. Let's plug in, instead of putting economic growth in there, put in the first stage. So economic growth is driven by rainfall, right? Do a little bit of algebra, and you get this equation. War is a function of this constant, which you can just see from the algebra, some constant on rainfall growth, the x's, and some error term. And the error term is complicated because it's the combination of the second stage and what we plugged in from the first stage. So what does this equation look like, everybody? The bottom row. What is the bottom row? The bottom row is the reduced form. We're regressing war on the instrument. So what we have here is that the reduced form coefficient estimate is actually just the product of B2 and B1, just from this totally trivial plug-in. So by plugging the first stage into the second stage, you get the reduced form. And what is the coefficient estimate on rainfall growth in the reduced form? B0. Therefore, B0 equals B1 times B2. Therefore, B2, which is what we want, is just B0 divided by B1. Got it? So you can just see that in this next step. So the algebra is sort of trivial, but if you think about the algebra, it's actually pointing you towards the causal story, which is saying, no, we're only using the variation in economic growth driven by the natural experiment of rainfall. That's what plugging in the first stage basically is doing. Okay, let me pause and see if there's any questions.